Right, welcome, I'm Mr. Simons. This lesson we're looking at identities, specifically those that have tan and the use of fractions. So whenever we have tan with adding or subtracting, tan is a fraction, and we will test whether you know how to add and subtract fractions. So, sorry for the fact that it's so long, but I've shown every process. So sine 3 theta divided by sine theta minus cos 3 theta over cos theta must equal 4 cos 2 theta. So you can see that's a double angle. There, 3 theta, 3 theta, theta. So take left hand side and I write it out like that. I need to introduce 2 theta into the two top values. So sine 3 theta can be written as sine 2 theta plus theta. Alright? Then cos 3 theta can be written as cos 2 theta plus theta. Right, but you see the denominators are different. So to add two fractions, they must always be the same. So I've taken the cos from here and I multiplied by cos theta over cos theta. And there I need to introduce sine, so I took the sine from there and I multiplied by sine theta over sine theta. Right, now according to my compound angles, sine would become sine 2 theta cos theta plus cos 2 theta sine 2 or sine theta times the cos theta over sine theta cos theta. Plus there, my cos compound angle would be cos cos, so that becomes cos 2 theta cos theta, right, minus sine 2 theta sine theta. That all is being multiplied by sine theta. Denominators are the same, right, so then only I can add the numerators, but let's see if we can simplify. So if I multiply cos in there, it will simply become cos squared theta. If I multiply in there, I would have cos 2 theta sine theta cos theta. The side with sine, that simply would become cos 2 theta cos theta sine theta, and this side if I multiply by sine, sine times sine would give me sine squared theta sine 2 theta. Right, now if you look at the top, sine 2 theta cos square theta plus cos 2 theta sine theta cos theta plus cos 2 theta sine theta, etc. So we've just written them all next to each other. So let's look if there's any like terms. Right, so sine 2 theta cos 2 theta minus, right, sine 2 theta there sine square theta plus cos 2 theta sine theta cos theta plus cos 2 theta sine theta cos theta. Right, so now if you look at these two, you should see there's a common factor there, sine 2 theta, that can be removed. I'm left with cos square theta minus sine square theta. If you look here, cos 2 theta sine, that's the same. So if I add these two, it simply becomes 2 cos 2 theta sine theta cos theta. Right? Cos squared minus sine squared can be written as cos 2 theta. Sine 2 theta, if I expand it, can only become 2 sine theta cos theta. There I've left that as it appears. Now I have 2 sine theta cos theta, right, cos 2 theta, plus 2 cos theta sine theta cos theta. So that and that's the same. 2 plus 2 would then give me 4 cos 2 theta for sine theta cos theta, sine theta cos theta. Sine and sine cancel, cos and cos cancel. Left with 4 cos theta, which then equal my right hand side. So it's quite a long sum. Won't test this long, but yeah, I've done one of these so that you can see. If you enjoy it, you can attempt it over and over till you get it right. It's nice practice. Also makes your brain sharper. The more you practice it, then you see things quicker. Right, next problem. Right, now here we have tan. So 1 minus tan theta, 1 plus tan theta must equal cos 2 theta, 1 plus sine 2 theta. So I work on the left hand side, I have 1 minus tan theta, 1 plus tan theta. Assume you know tan theta can be written as sine over cos, and there tan theta sine over cos. To add this fraction to 1, the denominators must be the same. So my denominator there is cos, so therefore I'm working with cos theta over cos theta. And there at the bottom, cos theta over cos theta, because that denominator is cos theta. So cos theta minus sin theta over my common denominator, cos theta. There, cos theta plus sin theta over cos theta. Change division to multiplication, so the top stays as it appears. The bottom we invert, so times cos theta over cos theta plus sin theta. Cos and cos cancel, and I'm left with cos theta minus sin theta over cos theta plus sin theta. Now that I can't simplify any further, but it doesn't look at like my right hand side. So now I have to work on my right hand side till it looks like my left hand side. So I take that and I write it for the right hand side. Cos 2 theta there, I chose cos squared minus sin squared. Right? The reason being there, I have cos theta minus and cos theta plus. So that is difference of 2 squares. The bottom, sin 2 theta will become 2 sin theta cos theta. And you should know that's a middle term for when we have cos squared plus sin squared. So 1 there, I've written as sin squared plus cos squared, which equal 1. So be careful of that. We've caught many people out. See, sin 2 theta with 1, we'll always go sin squared plus cos squared plus that. If I rearrange the bottom, I have cos squared plus 2 sin theta cos theta plus sin squared theta, which is a trinomial that can be factorized. Top, factorize via difference of 2 squares. So that becomes cos theta minus sin theta cos theta plus sin theta. My apologies, that must read plus. Come to the bottom, I have cos squared is simply cos times cos, which gives me cos squared. And the sin squared would be sin times sin. So cos squared plus sin squared will cancel with cos plus sin squared, and there, that is what's left. And now my left hand side looks like my right hand side. Right, to say my apologies, that must read plus. No? Right? I wish you nothing but the best. Let's look. I think there's a third problem. Let's have a look at it. Alright, so problem number 3. 1 minus cos 2b over tan b must equal sin 2b. So if we work on the left hand side, 1 minus cos 2b over tan b. By now, the quotient identity, you should know tan b must be sin b over cos b. Cos 2b there, whenever I have a cos double angle, I will choose the one that will cancel the 1. So yeah, 1 minus, and then I choose 1 minus 2 sin squared b. That way 1 minus 1 cancels, and negative times negative gives me 2 sin squared b over sin b cos b in the place of 10. Change division to multiplication, invert the bottom fraction, so cos go up and sin goes down. Sin squared divided by sin will simply become sin b, and times cos b, 2 sin b cos b. So double angle, if I reduce it, it becomes sin 2b, which now equal my right hand side. So I hope you enjoy the lesson. I hope you subscribe. I hope you stay up to date with what I'm doing, and feel free to ask any questions. I would do any lesson, whichever way. I've done all of this with the hope I help as many learners as possible. Continue striving for success.